Hello, this is the first long exam review ng Chem 34. So in this video, tatakol lang tayo on various spectroscopic techniques tsaka structure elucidation. So this review is divided into two parts. So we'll be doing multiple choice type questions sa una in the first part, and then we'll try to solve problems din mamaya. So ayun, let's go. So let's start with the first question ng multiple choice. So in this question, extending the conjugation in a molecule leads to a blank. This leads to a Batochromic shift, and siguro we can understand this better using yung molecular orbital theory natin. So during UV-vis absorption, the energy that we get from radiation is used to promote an electron, this electron daw, from the ground state to the excited state. So yung electron natin we promote that electron from the HOMO, or the highest occupied molecular orbital, to the LUMO, which is the lowest unoccupied molecular orbital. And we get that energy from radiation. We call this energy the minimum energy to promote this electron from the ground to the excited state, the HOMO-LUMO energy gap, this delta E. So let's look at this delta E. What happens to this delta E as we extend the conjugation, in this case in 1,3-butadiene, comparing that with 1,3,5-hexatriene. So as we build more atomic or molecular orbitals, in this case yung pi orbitals natin, nagbo-bunch up na yung additional molecular orbitals natin. So lumiliit yung delta E, lumiliit yung HOMO-LUMO energy gap natin. In effect, we need lesser energy to promote the same electron to its corresponding LUMO. So we go to the lesser energetic forms of light. This is the longer wavelengths of light. We see that here na yung butadiene initially absorbs at 217 nanometers, but when we increase the conjugation in hexatriene, it now absorbs at a longer wavelength at 258 nanometers. So the absorption here is redshifted, and therefore we experience it results in a bathochromic shift sa absorption niya. So the answer for this would be letter C. So for the next problem, which of the following compounds does not show a single peak in its H-NMR spectrum? So we have to identify now which of the following compounds does not has more than one type of proton sa kanyang compound. And let's label those hydrogens now. So pinakita lang natin yung hydrogens na meron yung compounds natin. So let's go to choice letter A. So in this compound, only yung methyl group sa bandang left has hydrogens. And we see na yung tatlong hydrogens na ito all experience the same chemical environment. So these hydrogens are all bonded to the same carbon, and they all have two hydrogen neighbors. So they experience the same environment dahil due to the fact that this bond is freely rotating kasi it's a single bond. So since it's freely rotating, these protons will just experience the same chemical environment, and therefore they're all chemically equivalent. So chemically equivalent protons just give off one peak in its H-NMR spectrum. So we'd expect a single peak sa spectrum niya. Let's skip muna letter B and let's go with letter C. So ayun, chemical equivalence is very closely tied with symmetry. So pag merong symmetry, or if yung molecule natin is symmetrical, there will be more equivalent protons, higher chance na merong protons in the same chemical environment with each other. So we see that in this compound, this is a highly symmetrical molecule, and we see a line. We can draw a line or a plane of symmetry down sa center ng molecule na ito, dividing it into identical left and right portions. So yung methyls dito, these methyls are actually just identical. These are chemically equivalent due to symmetry. So these sets of hydrogens dito are just the same with these sets of hydrogens dito. They will just yung key talaga is they just experience the same chemical environment. And therefore, since all of these protons are chemically equivalent, they would just give rise to one peak sa H&MR spectrum niya. We also see the same symmetry principle with the choice in letter D. In this molecule, we can draw a line of symmetry down sa center ng carbonyl groups. But also, we can find another line of symmetry on the horizontal, crosswise, dividing the compound into identical 4 sections. And so, yung 4 methylene groups natin dito sa vertices ng hexagon, sa vertices ng compound, are actually all chemically equivalent. So these 4 sets of hydrogens are just chemically equivalent. So they will all comprise just one peak sa H&MR spectrum niya. Let's go back to letter B. Right off the bat, makikita natin na there's no symmetry in this compound. So that would give us an idea that there would be more than one type of proton sa compound na ito. And sure enough, there is more than one. So let's compare this methyl group now to this methyl group. So these protons have a distinct environment, and it is different than the environment that these protons are experiencing. So this group is close to the carbonyl group. So yung carbonyl group natin has a shielding effect, diba? So we would expect these hydrogens to be more relatively downfield than a typical methyl group. Comparing that with this methyl group na yung adjacent, the group adjacent to it is just another alkyl group which has a lesser effect sa chemical shift niya. So since these have different neighbors, these have different environments, these protons are different than these protons. So yan pa lang, we have 2 different protons. But also yung methylene dito is also another type of proton, more so na it is singly bonded to our oxygen atom. So yung oxygen, electronegative oxygen also induces an effect sa chemical shift natin. So these hydrogens would also be relatively more downfield than the other protons dito. Since these are all distinct, we have 3 types of protons. We expect 3 peaks sa H&MR spectrum niya. And therefore, our answer is letter B. Okay. For number 3, given the structure of carbon, which labeled carbon is the most deshielded? So, this is a review sa usual carbon shifts natin sa CNMR. So, a rule of thumb in carbon NMR siguro is the 100 ppm mark. So at signals more than less than 100 ppm, these are usually sp3 carbons. The one on the right are usually sp2 carbons. So usually yung sp3 carbons natin are very upfield, relatively more upfield than the other types of carbons. And we'd see that around 5 to around 50 ppm. Comparing that to yung double bonds natin or the sp2 carbons natin. So sp2 carbons are typically more downfield dahil sa hybridization niya. So hybridization really has a big effect sa shift ng carbon na yan. So if we look at the labeled carbons ng carbon, this carbon sa letter A is an sp3 carbon. So and these B, C, and D are sp2 carbons. So this is the most shielded. So we can eliminate that choice. So it's between B, C, and D. When compared, if we look at yung carbon NMR tables natin, we see na yung carbonyl groups are yung pinaka deshielded. We see those groups around 170 maybe to around 200 ppm. Basta sila yung pinaka pinaka-left sa spectrum natin. So these are very deshielded since they are sp2 carbons and it is attached to an oxygen. So when we compare all these sp2 carbons, we would expect na yung carbonyl carbon on letter B would be the most deshielded carbon. So our answer is letter B. Number 4, ionized samples in mass spec are separated on the basis of which of the following? So the answer is mass to charge ratio. So in mass spec, we do not measure, we do not weigh the fragments directly. So it is by deflection. So in mass spec, yung fragments na nakukuha natin from fragmentation are accelerated inside a tube sa mass spec device and are deflected using an external magnetic field supplied by this electromagnet. And the extent of deflection is dependent on two things. It is dependent on the mass of the fragment, and it is also dependent on the charge. That's why we get the mass to charge ratio. And since unique yung mass to charge ratio ng each fragments, they will have different trajectories and will hit the detector at different locations, maybe at different rates. And therefore, magkaiba sila. They will be detected as different signals, and therefore makita natin yan sa mass spectrum natin that they are different signals. So in mass spec, it measures the mass to charge ratios of fragments. So the answer is letter D. Number 5, a compound with molecular formula C4H8O gives a strong peak around 1731 inverse centimeters and medium peaks around 3000. No other important peaks were observed in the group frequency region. Which of the following isomers is the compound? So since we're given IR data, it can give us an idea kung anong functional group meron ito. The first data of 1731, we can pinpoint this to yung carbonyl group natin. Carbonyl, the C double bond O carbonyl, the carbonyl stretch is usually around the same stretches, around 1700, and therefore we can assign this stretch as the carbonyl stretch. Meron naman tayong oxygen sa compound na ito. While yung around 3000, we can just assign these as the alkyl CH stretch. So ayun, it gives us an idea na our compound is a carbonyl compound. Therefore, we can eliminate letter B. We do not find an alcohol here since wala tayong alcohol stretch around 35. Wala din tayong sp2CH carbon. These hydrogens dito would also have a peak around 3100 na wala dito, so it cannot be an enol. It also is not an epoxide. An epoxide are all epoxides. The connections in epoxides are all single bonds. We would expect yung connections dito to be in the fingerprint region. Walang peaks masyado sa group frequency region, so it cannot be an epoxide as well. So it's between an aldehyde and a ketone. So how do we differentiate between the two? So sabi raw sa description, no other important peaks were observed in the group frequency region. So with aldehydes, this hydrogen gives off a special signal. We have the aldehydic shoulder. So this absorbs at around maybe 2700 wave number. So makikita natin yan with aldehydes. And since sabi naman sa problem na walang other groups na nakita sa group frequency region, it cannot be an aldehyde. And therefore, our compound in this case is a ketone. So we have letter A. Number 6, for 6 to 7, we have this molecule. How many distinct signals would be detected from the Nmr spectrum niya? So we'll just identify kung ilang different types of carbon this compound would have. So same thing as we did with yung the one kanina with hydrogen. It's almost the same thing with carbon. Let's look at if these carbons are chemically equivalent. So this is one type of carbon. Let's label it as C1. This is a different type of carbon. Magkaiba yung connectivity niya with compare that to C1. So this carbon is a distinct carbon. So we have C2. This carbon is C3. It is bonded to oxygen natin. So it also has a different environment. Yung carbonyl group natin is also a distinct type of carbon. So they all have, so these four carbons so far have different chemical environments and are therefore distinct signals sa H&MR spectrum natin. Also with this C5, yung carbon adjacent to the carbonyl group. So what happens between, what's with these carbons? It turns out that these carbons are actually equivalent. These carbons are chemically equivalent, same as sa rationalization natin kanina, na this bond is just freely rotating. So since freely rotating lang yung bond, they will experience the same environment. And therefore, both methyls are actually just chemically equivalent. So let's count na ilang distinct carbons tayo meron. So 1, 2, 3, 4, 5, and 6. We have 6 distinct carbons, and therefore we expect 6 distinct signals. So our answer is letter C. So for number 7, what would be the multiplicity arising from the highlighted proton, which is this proton? So multiplicity or splitting happens with the proton and its neighboring protons. And this proton has the protons ng methyl group as its neighbor. So ipakita na natin yung neighbors niya. So these protons interact with the highlighted proton. And with this, we'll just follow the multiplicity rule, n plus 1, where n is the number of neighbors. So since we have 6 protons as neighbors, so 6 plus 1, this proton would give a septed signal or would have a multiplicity of 7. So our answer would be letter D. Number 8, which of the following compounds would exhibit a 1-to-1 ratio between its M to M plus 2 peak heights? So yung M plus 2 natin sa mass spec is usually attributed sa mga natural isotopes, sometimes the heavier isotopes of oxygen, sometimes sulfur. But most of the time, or the most prominent peaks, M to M plus 2 peaks natin, is with chlorine and bromine, and they both have different ratios. So for Cl, for chlorine, it roughly has a 3-to-1 ratio sa peak heights niya. So this is roughly a third of this height. Meanwhile, yung bromine natin is at almost a 1-to-1 ratio ng peak heights nila. This is just due to the natural abundance ng both isotopes ng chlorine and bromine. So let's go back to the problem. Since it exhibits a 1-to-1 ratio ng M then M plus 2 peak heights niya, we would expect it would have bromine, and in the choices, only letter A has bromine. So the answer will be 1-bromopropane. Number 9, which of the following pairs of molecules cannot be distinguished using UV vis? So we'll be using Woodward-Pfizer rules to predict the lambda max ng mga, or to have an idea ng lambda max nila, and see if they can be distinguished using UV vis. So let's look at letter A. So if we look at the conjugation system ng letter A, we have an extended conjugation. We have these 3 double bonds, including the carbonyl group. And we also have 3 double bonds here, including the carbonyl group. So since they have the same conjugation system, what would make them different, or different ba sila? And it turns out they are different dahil sa different connectivities nila. So let's look at yung alkyl substituents nila. So the one on the left, if we look at the alkyl substituents ng the one on the left, it actually has 3 alkyl substituents. So it has 1, 2, tsaka 3. It has 3 alkyl substituents sa compound on the left. Meanwhile, yung compound on the right only has two. So it only has two alkyl substituents sa conjugated system niya. It would also differ sa number of exocyclic bonds that the compound has. Exocyclic bonds. So the one on the left has two exocyclic bonds. So this bond is exocyclic with respect to this ring, and this bond is exocyclic to this ring. So meron tayong dalawang exocyclic bonds sa letter A. Compare that with letter B na meron lang siyang isang exocyclic bond, which is this one, with respect to this ring, and wala nang iba. So it has one exocyclic bond for the compound on the right. So since magkaiba yung influence or contribution, since they have different alkyl substituents, they have different number of exocyclic bonds, they if we sum that up, we would have different lambda maxes between these two compounds, and therefore they can be distinguished using UV-Vis. So letter A can be distinguished using UV-Vis. So let's look at letter B. So these compounds just differ sa placement ng carbonyl group niya with respect to the benzene ring. And if we look at it, magkaiba sila ng conjugation system. So for a conjugation system to be connected, it only has to be a single bond away. So we see that with this compound. So the carbonyl group is just a single bond away from the conjugated benzene ring. So connected yung conjugation natin dito. This would be our conjugation system. Meanwhile, the one on the right is separated by more than one bond. So sobrang malayo na ng carbonyl tsaka benzene. So these groups are actually not conjugated. They are isolated from one another. And so since magkaiba yung conjugation system nila, they would have different lambda max, and they can be distinguished using UV-Vis. So letter B can be distinguished. So with letter D, draw lang natin yung conjugation system niya. For this would be the conjugation system on the one on the right. Meanwhile, the conjugation system on the left would only be this portion. So bakit hindi natin sinali ito na it's just one bond away rin sa last pi bond? So in conjugation systems, all the pi orbitals must be parallel to each other, or the way I take it is it follows just one direction. So it has one direction ng conjugation. So if we follow the conjugation starting from the carbonyl group, if we go like that, and this bond, we would expect na yung double bond, yung next double bond would be around here, similar dito. Pero the double bond in this case is here. It is not parallel with respect to these pi orbitals, and therefore this double bond is not conjugated with the conjugation system. Since magkaiba naman sila ulit ng conjugation system, these would be different. They would have different lambda max, and therefore can be distinguished sa UV-Vis. So the answer is letter C. And we see that actually, kasi if we verify yung connectivities nila, this is just actually the same compound redrawn differently. Maybe a trick question. Pero since this is just the same compound, they would have the same lambda max. They cannot be distinguished using UV-Vis. So our answer for this problem would be letter C. For number 10, which of the following analytical techniques is a destructive method for structure elucidation? So the answer for this problem would be mass spec. So unlike with UV-Vis, with FIR, with NMR, which does not destroy the sample, we can do multiple tests on a sample because it's non-destructive. In order to study a compound in mass spec, we have to break it down. So for example, here in acetone, we have to make it a radical, and it has to undergo fragmentation in order for it to be studied or to be detected in the mass spec. So ayun, yung acetone natin becomes an acylium ion and a methyl radical. We are left with different compounds as we started with. So we lose our initial sample, so it destroys our initial sample. Therefore, it is a destructive method for structure elucidation. Ayan. So mass spec is a destructive method for structure elucidation. Letter A. So for number 11, what would you expect in the proton and carbon NMR spectra of 2,3-dimethyl-2-butene? So let's draw that quickly. So this will be the structure of 2,3-dimethyl-2-butene. And let's look at the choices of this problem. So it says in letter A, the proton NMR spectrum would have 4 different signals. And let's verify if tama ba. Again, with chemical equivalence, yung first thing I do is find any line or plane of symmetry. And in this molecule, it has 2. So we can draw that symmetry line sa double bond. And we also have a vertical line of symmetry. So it divides the compound into 4 identical sections. So yung hydrogens natin dito sa methyl groups are all equivalent. They are all experiencing the same chemical environment. And dahil dyan, they would only comprise 1 peak sa HNMR spectrum sana. HNMR signal sana. So letter A is false. Letter B, all the different carbons in the structure are relatively upfield. This is false dahil although we have a relatively upfield methyl group, which is sp3, we do have an alkene carbon, which is sp2. So sp2 again was relatively downfield. We see that above 100 ppm. Meanwhile, yung mga methyls natin are below 100 ppm. So we cannot group them together as relatively upfield. Therefore, letter B is also false. Letter C. So the Det90 NMR spectrum daw shows 2 signals. So yung Det90 sa carbon NMR shows a positive signal pag meron tayong methane group. So yung methane groups nga are just CH groups. So C tsaka isang H. Meanwhile, magkaiba yung connectivities dito. So we only have a CH group. And if we verify dito sa structure ng compound natin, it does not have a methane group. And therefore, it would have not shown a signal sa Det90 spectrum niya. So letter C is false. So we're left with letter D, yung broadband decoupled NMR spectrum niya exhibits 2 distinct peaks. And tama nga, since we have 2 different carbons, we have the methyl carbon dito, 1, and we also have the alkene carbon dito. So we have 2 types of carbons and it would exhibit 2 distinct peaks sa CNMR spectrum niya. So letter D is the answer for number 11. So for number 12, compound Z shows a sharp medium peak around 3300 wave number. Upon performing Hintsburg test, precipitate formation was observed. Which functional group might compound Z have? So it gives us IR data. So it says my sharp medium peak down around a given wave number. And with this information, we can cancel out an alcohol. This is not an alcohol because usually yung alcohols have higher wave numbers than 3300. They can be seen around 3600, but maybe can reach 3200. So another criterion why this cannot be an OH stretch, because OH peaks, OH stretches are strong and broad. So malalaki and malalawak yung peaks ng OH natin, while this peak only shows a sharp medium peak. So we can exclude na hindi siya OH, wala siyang OH group, and therefore it cannot be an alcohol. This also cannot be a primary amine kasi although it has peaks around 3300, a primary amine has 2 peaks around 3300 due to the symmetric and asymmetric stretching ng both NH bonds sa primary amine. So it cannot be a primary amine. So it can only either be an amide, or in this case a secondary amide or a secondary amine. So how do we differentiate between the two? It's given sa next piece of information natin that they performed Hintsburg test. So Hintsburg test is a test for amines. It differentiates between the primary, the secondary, and tertiary amines using yung benzene sulfonyl chloride natin. So upon performing yung Hintsburg test natin, it reacted in the Hintsburg test and it formed an insoluble solid here. So since it tests positive sa Hintsburg test natin, it is a secondary amine, and it is our answer would be letter D, yung secondary amine. And tama naman, according to the Hintsburg test, a secondary amine would produce a precipitate. And so the precipitate formation might be the insoluble solid we found when compound Z reacted sa Hintsburg test. So that's for number 12, we have a secondary amine. Number 13, which 2D NMR experiment is employed in the following spectrum? So for this, let's look at the axis ng 2D NMR dito. So in this axis, we have it has the carbon NMR. Meanwhile, the vertical axis has the H NMR. So the spectrum that compares yung carbon and yung protons natin is het-core or heteronuclear correlation, if I'm not mistaken. Het-core. So yung het-core assigns which protons are bonded to which carbon. So it gives us a powerful information on the linkages that the compound has. So which protons, for this case, this proton realm is connected to this carbon dito. So it gives us very important information on that. If we contrast that with COSI, COSI has both the proton NMR sa axis niya. And another distinct feature ng COSI is there's a diagonal line sa diagonal ng spectrum niya. So in COSI, it looks at the mutually coupled protons. So it looks at which protons, which hydrogens interact with which other hydrogens sa compound na yun. So we get that information with COSI. But going back to the problem, since it has a carbon NMR sa one axis and a proton NMR sa other axis, we have het-core. NOSI and ROSI are just advanced forms ng 2D COSI natin ngayon. So ayan, that's for number 13. For number 14, the mass spectrum of 3-pentanone, pentanthreone, produces a base peak of 57. Which of the following fragments would cause this line? Draw lang natin ng madali yung picture ng 3-pentanone. So this is the structure of 3-pentanone. And by looking at the structure, hindi natin to nakikita since yung branches ng ketone natin are just ethyl groups. So wala tayong nakikita na 4 carbons. So we can eliminate D and E, C and D. So which of the following would give that signal, either A or B? So in mass spec, it only detects yung charge fragments natin. So only fragments only the cation fragments are recorded. The neutral radicals are not recorded sa mass spectrum natin. So we can exclude B, and therefore our answer is letter A. And if we look at a common fragmentation pattern of ketones would be which is the alpha bond cleavage. If we cleave an alpha bond here, we would get the same we would get this fragment. So this fragment is the one with letter A. So the fragment that produces the base peak is in letter A, the acylium ion. Number 15, arrange the following series of analogous compounds with increasing extent of conjugation given their observed colors. So compound 1 was red, compound 2 is orange, compound 3 is red, compound 1 is green, orange, red, and compound 4 was violet. So for this, we'll have to look at the color wheel. Kasi the colors that are being reflected, yung complementary niya will be the color that the wavelength of light that is absorbed. So if we take that all down sa table, sa isang table, so compound, the color absorbed, and the color reflected na lang muna. Color reflected and the color absorbed. So for compound 1, it reflects green. We see it as green, so it reflects green. And therefore, you have to check the complementary color niya. The complementary color of green is red, so it absorbs red. Compound 2, it reflects orange. So yung complementary niya, it would absorb blue. According sa ano natin dito. Compound 3, since it reflects red, it absorbs green. And same thing with compound 4, since it reflects violet, it absorbs yellow. So in order to arrange our compounds with increasing extent of conjugation, we'll have to look at the wavelength of light absorbed. And balikan natin yung first question on Batochromic shift. So as we increase the conjugation, the absorption, the wavelength of light is now longer. So yung longer wavelengths of light would be more conjugated. So longer wavelengths are more conjugated. Meanwhile, yung shorter wavelengths are less conjugated. So it's a matter of arranging, I'm spelling niya. It's a matter of arranging these four dito. So yung pinaka short wavelength would be the least conjugated, yung longest wavelength would be the most conjugated. So if we arrange that accordingly, yung least conjugated would be the one that absorbs blue light. Next would be the one that absorbs green light. Then the one that absorbs yellow. This is just, and the one that, and lastly, the one that absorbs red. So, ano lang, as we go to longer wavelengths, and let's assign na lang the compounds accordingly. So, yung blue light, the one that absorbed blue light is compound 2. The one that absorbed green light was compound 3. The one that absorbed yellow was compound 4. And the one that absorbed red was compound 1. So we have this arrangement, 2, 3, 4, 1, which we see in letter B. So our answer would be letter B. Number 16, which of the following highlighted bonds is IR inactive? So in IR, a net change in dipole must occur in vibration for a vibration to be IR active. So yung polar bonds natin are very easy. They do create a dipole moment when they are stretched. So yung carbonyl group natin, since this is a polar bond, we'd expect a net change in dipole moment when this is stretched. And also this nitrile group dito, since it is polar, we'd expect a dipole moment when this is stretched. And tama naman, carbonyl groups are very strong, have very strong peaks as a IR spectrum natin. Also, nitriles can be seen sa IR spectrum natin. So, we are left with letter A and letter C. So, with nonpolar bonds, we'll have to go back ulit with symmetry. So, a double bond or a triple bond that is centered along a line of symmetry is IR inactive, since either side would be pulling on it with the same force. So we would not see a change in dipole moment sa bond na iyon. So if we mark a line down sa center ng triple and double bonds dito and look at either sides to see if same ba yung left and right side niya. Sa letter A, magkaiba yung substituents niya, the right and the left. This has an ethyl group. Meanwhile, dito, it has a propyl group. So since hindi same yung left and right sides nila, this would give a net change in dipole moment when in-stretch natin yung triple bond. But with letter C, since yung left side natin is just the same as with the one on the right, if we stretch this double bond, you would not see a change in dipole moment kasi same lang yung substituents either side. And therefore, this bond would be IR inactive. Therefore, answer is letter C. Number 17, which of the following compounds can undergo N to pi star electronic transition except black? So for N to pi star, N would be the non-bonding electron pair, non-bonding to pi star. So for this to happen, it must have non-bonding electrons, and it also must have a pi bond. And if you look at the choices, lahat naman merong pi bond, pero yung letter B does not have non-bonding. It does not have a lone pair. So we must have a lone pair and a pi bond for an N to pi star electronic transition to happen. So since all the carbons here do not have a lone pair, therefore we cannot have an N to pi star electronic transition sa letter B. So in this problem, we are to rank the following labeled hydrogens with increasing chemical shifts. So let's this is just a review yung usual chemical shifts natin ng H-NMR. So let's take note lang with what types of hydrogen yung labeled hydrogens are. So HA is a methyl H. So since there are two H's pa dito, HB is a methine H, and HC is an aldehyde the aldehyde. It's an aldehydic H, and alcohol yung alcoholic H yung letter D. So if we compare these four groups, alcohol, an aldehyde, and alkyl groups, we can say now the alkyl groups are the most relatively the most upfield, but it begs the question between which methine or methyl is the most upfield. So for alkyl groups, as we substitute more carbons into the alkyl groups, the hydrogen becomes more downfield, more shielded. So yung methyl natin would be the most upfield, followed by yung methylene. So methylenes would start to become downfield na. And last is our methine groups. Our methine groups are relatively more downfield compared with yung methyl group natin. So as we substitute more carbon groups sa alkyl groups natin, the proton becomes more downfield. And therefore, if we rank between the methyl and the methine, this would rank number 1, and this would rank number 2. So the only groups left is the alcohol and the aldehyde. So alcohols, since the hydrogen in alcohol is bonded to electronegative O, it is naturally deshielded, and uh, we find these shifts at around 3 to 7 ppm. But yung aldehydes natin are bonded to the carbonyl group, and carbonyl groups have a very strong electron withdrawing effect to this hydrogen. Now it strongly deshields this hydrogen. We see this at around maybe 9 to 10 ppm. Therefore, if we compare yung shifts nila, our third would be yung alcoholic H, and our last would be the aldehyde H. So if we follow our ranking, it would be HA, followed by HB, followed by HD, and lastly, yung pinaka-deshielded natin, yung pinaka-malaking chemical shift would be HC. So our answer would be letter C, HBDC, ABBC. Number 19, which of the following carbons in a compound cannot be observed in depth 45, in its depth 45 spectra? So depth 45, only gives positive peaks to yung methyl groups natin, methylene, and methine. So any carbon that has a hydrogen attached to it has a positive signal or exhibits a signal sa depth 45. It cannot measure quaternary carbons or carbons na walang quaternary carbons, or yung carbons that have no hydrogen. And so if we look at these carbons that are in the choices, so A is a methine carbon, C is a methylene carbon, D is a methyl carbon, and B is a quaternary carbon. We cannot find the quaternary carbons at depth 45. So our answer would be letter B. And lastly, for multiple choice, we have this problem. For mass spec analysis, the molecular weight of an unknown compound was found to be 60 atomic mass units. Which of the following cannot be the formula for the unknown compound? So we can tackle this in two ways. Of course, we can solve for the molecular mass ng each formula to find which of them does not add up to 60, which we can do, and we can show that result na letter B, yung hindi 60 atomic mass units. But we can also find an easier way through the nitrogen rule. So yung nitrogen rule natin states that if my odd number of nitrogens, it would have an odd molecular weight value. But if we had even number of nitrogen, it would have an even molecular weight. So if you look at it, yung molecular weight natin, which is 60 AMU, is even. So it would have an even number of nitrogen atoms. It can be 0, 2, 4, and so on. And therefore, yung choice B natin has 1. So since it has an odd number of nitrogens, it cannot have an even molecular weight. Therefore, our answer for this problem would be letter B. So we can solve the molecular masses for all these compounds, but the simpler way would be to use our nitrogen rule. So yun yung for number 20.